Welcome to myprojectbuzzer.com. Next we are going to see the abstract for our product. In the near future, billions of devices will be interconnected, enabled by the Internet of Things. Several applications are envisaged in different domains including transportation, agriculture, smart homes and healthcare. The transition from idea to reality depends on addressing problems which remain unsolved. As stated in the visionary paper by Weiser, the most profound technologies are those that disappear. However, the physical size as well as the cables used to deliver energy to current IoT-enabled devices is not compatible with the ongoing paradigm shift. Both constraints are related to the method of supplying energy to the devices or how efficient they are in terms of power consumption. Miniaturized embedded systems with wireless communication links are not rare nowadays. However, they require at least coin cell batteries which define the form factor of the IoT device. Considering the healthcare applications such as body area networks, several IoT-enabled wearable or implanted devices are foreseen to be carried by a person. In order for these kinds of IoT to disappear, they need to have energy autonomy to avoid discomfort of the part of the user. Energy harvesting from the surroundings or wireless power transfer are candidates to replace energy carriers in miniaturized circuits. The design and measurement of an inductive link for transferring energy to a fully integrated wireless power receiver is implemented in this product. Next we are going to see the flow diagram for our product. Our product consists of the receiver side, where it consists of magnetic coupling block and RF2 DC which is rectifier, then the variable load PSCO and the backscattering switch. The receiver is constrained to be fully integrated in a CMOS die. The design of the receiver building blocks is implemented here. The inductor is perhaps the most challenging component in a CMOS integrated wireless power transmitter receiver due to its proximity with the lossy substrate and to the fact that it must occupy the outermost area of the chip to maximize the enclosed magnetic flux. A widely accepted technique to improve the quality factor is the use of patterned shields below the inductor. The rectifier topology is based on its high efficiency and simplicity. The stages selected was for the NMOS transistors or triple well devices, and thus their sources can be connected to their body terminals, thereby keeping at minimum the voltage required to turn on the NMOS transistors. A PSCO is suitable to convert the amount of received power into a frequency quantity. Moreover, the PSCO consumption is a function of VDD and thus its equivalent load RV can be adjusted to the desired curve. The PSCO is based on a 7-stage ring oscillator. A frequency divider based on a flip-flop is used after the oscillator to guarantee a duty cycle of 50%. The output signal VSW controls the switch responsible for this backscattering response. The level converter block generates the VSWLV signal to drive the switches. The switch is used for the load modulation. Two NMOS transistors are connected between the terminals of the inductor. Their lengths were kept at their respective minimum values to decrease the on resistance, while their widths were designed to keep the on-off amplitude ratio higher than 10. Other transistors were used to tie RF plus and RF minus down to ground, aiming to decrease the on resistance of the main switch. Next we are going to see the output for our product. We designed the circuit in the Tanner version 13.0. To create a new project, you have to click on the file and then click on the new and then give the new design. Then to add the library files, you have to click on the add and then give OK to add these components. Then for the new cell, you have to click on the cell and then give the new view and specify the name to which you have to give to your design cell. Then you have to click on the setup and then you have to click on the space simulation and give and specify the folder in which you have stored your library file, and give the library file, and you have to browse and then click on the generic file and then give the space tt. Next we are going to see the output waveform. Then run the program. The output waveform will be created. Thank you.